In this video, we are going to explain about the project title Snake Species Identification and Recognition. With around 81 to 137 deaths per year, snakes are among the top 3 dangerous animals for human. Out of the 3,848 known species of snakes, around 800 species are venomous, among which only about 50 species are fatal to human. Identification of snakes is not easy. For example, those characters discriminating the non-venomous snakes for the vibrates oval-shaped head, round pupil, absence of pit occurs in the elliptic snake either, while both vibrates and elliptids are venomous or fatal to the humans. Hence, proper snake identification would entitle hetopathological skills that uses body and head morphological features like a color, pattern, shape, scalations, and etc. Automated snake image identification is important for different points of view. Most importantly, snake bite management. Auto identification of snake images might help people avoid venomous snakes. Besides, it can help healthcare providers plan a better treatment for patients bite by the snakes. The main objective of this problem by using pre-trained DenseNet 169 CNN based algorithm to recognize snake species. So in this project we are going to use AI crowd snakes species dataset to train the DenseNet 169 algorithm, and we are going to use 32 different species of snakes, and this dataset has many more species, but training model was taking more time, so we restricted model to get only trained 32 species. Hardware requirements: we need operating system Windows, processor i5 and above, RAM 4GB and above, hard disk 20GB and above. Coming to the software requirements, we need to install Python with the version of 3.7. Methodologies: to implement this project we have designed few modules. First one, upload snake species dataset. Using this model we will be uploading the dataset to the application and then find the different species found in the dataset. Second one, pre-processing dataset. Using this module we will read each image and then resize image to equal size and then normalize pixel values and then split the dataset into two, training and testing, where application used 80% of images for the training and 20% of the images for the testing. Third module, train DenseNet 169 algorithm. Using this module we will input 80% of images to train DenseNet 169 model and then apply 20% of test images on the trained model to calculate prediction accuracy. Fourth module, Dense 169 training graph. Using this module we will plot graphical representation of DenseNet 169 training accuracy and loss graph. Fifth module, snake species classification. Using this module we will upload the test images and then DenseNet 169 will analyze image and then recognize species. Now coming to the execution, close this file and go to the code file. This code file consists of dataset file which contains different types of species of the images of snakes. Now this is the model file which contains pickle file, .h5 file and .npy file formats. .pickle file is a serialized data format in Python used for object serialization. It also allows you to save Python objects into a file and later load them back into the memory. Then coming to the .h5 file contains algorithm information which can be loaded into the project code during runtime to utilize the trained model for various tasks such as making prediction on the new data or performing specific operations. Next module, .npy format file is the standard binary file format in NumPy for persisting a single arbitrary NumPy array on disk. The format stores all the shapes and data types informations necessary to reconstruct the array currently, even on another machine with a different architecture. Now next, these are the test images used to test the algorithm, and these are the main code files, and this is runbat file. This runbat file, instead of executing the program in command line interface, we created Windows bat file to execute the project. By clicking double tap on it, it leads to the user graphical interface which is interactive to the program user. Now click on the first button, upload snake species dataset. You can see the dialog box open and select the folder dataset and click on the select folder. So it will generate the path of the dataset where we have selected, and it will load the dataset, and it will show the 32 formats of species of the snakes. Now click on the pre-processed dataset. By clicking this button, you can see the dataset was read, pre-processed completed, and also the records present in the image dataset of the snake species was divided into 80% of the dataset for the training DenseNet 169 algorithm, and 20% of the images are used to test DenseNet algorithm 169. Now click on the train DenseNet 169 algorithm. So in this process, it will build the model by using 80% of the images trained, and also predict the accuracy based upon the test images 20% of the images which we have divided, and all for the DenseNet algorithm. So after the training part and the testing part, it will generate the accuracy for the training of the DenseNet algorithm 169. So on the screen you can see the different types of species, and also you can see the confusion matrix of the DenseNet 169 accuracy. Close this graphical representation. On the graphical user interface, you can see the accuracy, precision, recall, and F1 score of DenseNet algorithm 169. Now click on the DenseNet 169 algorithm. Now you can see the graphical representation of DenseNet 169 training accuracy and loss graph. On the red line, it indicates the loss of the DenseNet 169 algorithm, and green line indicates the DenseNet 169 accuracy. X-axis indicates the approaches, and Y-axis indicates the accuracy or loss graph frequencies. Now close this gun and click on the button snake species classification. By clicking this button, you can see the dialog box open, and select any of the images and click on the open button. By this image, using DenseNet 169 algorithm, it identifies the snake species recognized as different species is what it belongs to. Now close this one and check with the another image. Same, click on the button and select the one more snake image and click on the button open. Snake species recognized as Tomostian ciristolis. So in such format, using DenseNet 169 algorithm, we can find out what type of species of snake it belongs to. Now click on the exit button to exit the whole process of the code. Now go to the conclusion. In this project, we have found that by using snake species identification pre-trained with the algorithm, DenseNet model with the classifier shows good accuracy in the classification of snake species. It can also be observed that with the help of the transfer learning techniques, we can save the time and consumption resources.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.